All right, we want to talk about drawing the graph of a sequence. You should have already watched the video that explains how to do that. I don't have the fancy calculator program that was shown in the video, but I will go over which buttons to press, and I've written a bunch of terms along the side so that you can fill in the information as we go. If you're having problems with this after you've watched the video and after you've watched this part of the lesson, please come and see me and we'll go through it together. So we're going to do page 445, number 27, which says, draw a graph of the sequence AN. And for number 27, we're told that U1 is equal to 2 and UN is equal to 3 times UN minus 1 for all n greater than or equal to 2. Now, the first thing that you need to notice here is that the instructions talk about a sequence A sub n, and that the problem is using the symbol U. Well, we all know that we're talking about the same sequence, and we're not going to get hung up on that. So the problem tells us that the first term of our sequence is U1 is equal to 2, and then we're given a term for any other term of our sequence, and that's UN is equal to 3 times UN minus 1. And that expression right there gives you two pieces of information about the sequence. Can you tell me what one of them is? Well, you know that this is a recursively defined sequence because UN depends on the term before it. So for instance, if we were going to write the U2 term, it would be equal to 3 times the U1 term. The U3 term would be equal to 3 times the U2 term, etc. And because each time we generate a new term, we multiply it by 3, we have this common ratio, and we know that this is a geometric sequence. So let's talk about how we would plot this. The first thing that you want to do is to make sure that your calculator is in sequence mode. So you're going to want to hit the mode key. And 4 lines down, you have 4 options: func for function, par for parameter, pol for polar, and SEQ for sequence. So you want to make sure that sequence is highlighted and you want to hit enter. And then on the next line, it says connected dot. Well, you want to make sure that you highlight dot and hit enter. And this will allow each element of our sequence to appear on the graph as a separate dot. Connected means that we would connect those dots, and that might not be as helpful. So after you've set up your calculator properly, you want to exit out of there so you can hit second mode, which will help you quit. And then we want to set up our graph. So we're going to start by pushing the y equals key, just as we would for any other graph that we would make. And you'll find that this looks a little different than it usually does. So first of all, you see that we have n min is equal to 1, and that's just to tell us what the first term in our sequence is. So we're going to leave that the way it is. Now we're going to have to fill in the expression to generate all of the other terms in our sequence. Now in other examples, our sequence has been explicitly defined. So UN would have just been a function of n, and we could have entered that in. So this is a little different because UN is defined recursively. Well, I'm going to start by typing in a 3 because I know that whatever I'm going to do, it's going to be 3 times something because that's how the general term of my sequence is defined. And now I need to find a way to put in this UN minus 1 term. Well, it's really going to be a function U of n minus 1. So we need to start by putting the U in. And if you look at your calculator down here by the 7 button, you'll see to the upper left-hand side a little yellow U. So to get that U, because it's yellow, we're going to hit the second key and we're going to hit the 7 key, and a little U will pop up right there. But this is going to be a function, so we're going to want to open our parentheses, and it's going to be a function of n minus 1. So n is our variable. It's the thing that we're changing. It's going to be 1, 2, 3, 4, to however many terms in the sequence we want to graph. Well, whenever we have a variable, we use our variable button, which is right there, and it has x, t, theta, and n. So if you press that button, it'll come up with an n all by itself. and then we're going to put in -1, close our parentheses, and hit enter. So this tells us when n is equal to 2, it'll figure out what n of 2 minus 1 or u of 2 minus 1 or u of 1 is, and it'll plop it in here, multiply it by 3, and we'll get the next term in our sequence. So to do that, though, you have to tell the calculator what the first term is. You have to tell it what u of n min is, what u of 1 is, and we are given that. U of 1 is equal to 2. You could, of course, have a sequence where maybe it doesn't start with U1, maybe it starts with U4, and then you would have to change this to a 4, and you would have to change this value to whatever it was defined as. So we've set up what our equation is going to be, and now we need to set up our window. So you can either hit second mode and quit out of here, or you can just hit the window key. And again, you're going to see a whole bunch of options that aren't usually there. So the first one is n min, and we're going to let n min be 1. These are the values of n that we are going to look at. And I usually feel that when we do this, you want to look out to about n equals 10. You want to look at the first 10 terms, and that will give you a sense of what the sequence is going to look like. So we'll let n min be equal to 1, n max be equal to 10. The next option is plot start, and you want to let the plot start at 1 because that's going to be our first n value. Because n is integers, it's going to be 1, 2, 3. You want your plot step to be 1. Now we need to figure out what we want our x-axis to look like. Now, what's being plotted on the x-axis? Well, our n values are plotted on the x-axis. So you want your x min and your x max to be the same as your n min and your n max. I am often taken to making x min equal to 0 because I like to start my x-axis at 0. It's not really going to make a big difference. There'll just be a gap where there's not a plot at the very beginning. And I'm going to let x max be equal to 10. I'm going to let my x scale be 1 so that if I want, I can read each n value off of the graph. And then we have to look at our y min values. Now, I want to look at the terms of my sequence. I know that it starts with a value of 2. And then what's the second element going to be? Well, it's going to be 3 times the first element, which is 2, or it's going to be a 6. So I'm thinking that I'm going to have all positive values here. I know that my U3 term is going to be 18. My values are going to be positive and increasing. So I'm going to let my y min be equal to 0. And then I need to know what my y max is. Now, because I've done this problem before, I happen to know that the 10th element in my sequence is 39,000 and something. So I'm going to let my y max be 40,000. And then I know that the last point, since I'm going up to 10, that the last point in my sequence will be plotted on my graph. Let's talk about y scale for a moment. I could leave it equal to 1, like my x scale, but then my entire y scale will be filled with the little tick marks, and it's probably not going to be very helpful. So I'm going to let my y scale be equal to 10,000. And now we're ready, and you can hit graph, and we're going to get a plot that looks something like this. So on my x-axis, I'm going to go from 0 to 10. On my y-axis, I'm going to go from 0 to 40,000. And you should see some individual points. Now mine, I'm just picking up my last 3 points, n equals 8, 9, and 10. And the reason for this is my y scale goes from 0 to 40,000. And my first term is 2, and my second term is 6, and my third term is 18. And those points are going to be plotted so close to the x-axis that I'm not going to see them. So I can see that my sequence is increasing and will probably continue to increase. So if we wanted to talk about what the limit of this sequence was, is it going to be a finite number? Is it going to be 80,000? Or is it going to be infinite? Is it going to be infinity? What would you say? Well, I think this sequence is going to have a limit that goes to infinity because each new point is going to be 3 times the point before it. So those points are just going to keep getting bigger and bigger and bigger and bigger and bigger as my n values get bigger and bigger and bigger.